Hello, this is Harry from Deep Sky Watching again. Today I have a video about the topic CMOS camera. Is it useful to bin my pixels in the luminance channel or is it not helpful? And I will show you after the intro my image of Messier 51, which I took in May this year. And I will show you the difference between 2x2 binning and 1x1 binning and what's the result of both images. So first of all, we should make a little clarification about what is CMOS and what does binning do in the CMOS. So if you are aware of the CCD technique, there was the binning be done in the hardware itself, in the camera. And on CMOS, this is normally not possible. So either if you do it on your imaging session with bin 2 or afterwards in the software, it's the same because CMOS does not support hardware binning. The camera is doing it by software as well as PixInsight does. So what's the theory behind binning or not binning, and how is it related to the focal length I use and the pixel size I have and the seeing conditions and all these things? So this is quite complicated, but to help you and help us, Astronomy Tools has released a software web application where you can check whether your focal length and your camera sensor will lead to a good resulting sampling in your image or not. So on the one hand, you can have an oversampling, so your resolution is much higher than the seeing allows. Or you have an undersampling if it is the opposite, which leads to, let's say, blocky stars. So I've put in my focal length of 1.25 meters and my CCD camera, the IMX571 sensor with 3.75 micrometer of pixel size, and the result with okay seeing. So this is mostly the case. So between 2 and 2.5, maybe 3 FWHM values. So this will lead to a slight oversampling. So the idea behind going to bin the data is on the one hand to raise the suitability. So if we switch to 2x2 binning, you can see that the resolution is climbing to the double amount of 1.24 arcseconds per pixel, which leads to the green zone, which practically is ideal with no loss of resolution. And so that is the clue why considering binning. So you get no loss of details, but if you bin 2 pixels together, the amount of light what you can gather with 4 pixels against 1 pixel is logically you can collect 4 times more light in the image. So this leads to a higher signal to noise ratio at no cost to the resolution. So that's the theory. And we will check in the image now whether this theory is correct or maybe not correct. So this is the result of both images. Now the left side is binning 1 and the right is binning 2. So it's the final stack. I did not remove any gradients or something like this, just to show you the images from the distance look very similar. So the first what I have checked is the signal to noise ratios. So let's check the difference between both images with the SNR check, and you can see the bin 2 image has an amount of 51 signal to noise. That's really good. And the other one has 43 decibel. So the difference is around about 8 decibel. The first thing what I wanted to show you is how to get bin 1 images into the bin 2 format. So that's a little bit a clue necessary. You have in PixInsight the integer resample function, but you do not want to do this with, let's say, 50 or even more images. So we have to make a little trick. So here comes very handy the image container. So if you open the image container, you are able to add files to this system by just clicking here this order symbol here. And then you can open your master files wherever they are. Let's say this is a different file, but to make it show to you, it's enough. So I can make out of this 3 images, 1 image container, put it aside, and then put the integer sample on this. So, and then it's starting a batch program where all the images which are in the container are resampled to the value what you want. And here's the value 2. So now we have bin 2 times 2 binning in the resulting images. You can define your output directory and so on. So, and here is the result of both images. The left one is binning 1, the second one is binning 2. And I made here a little processing in PixInsight. Nothing complicated. I even did not remove the stars because I wanted to show you the difference in the result, bin 1 versus bin 2. And on the first of vision, you can see that the right one, that the stars are a little bit brighter than on the left one. This is normal because we have here a better, or let's say a higher sampling rate, because we have seen that the resolution was going up to 1.24 per arc second. And to be honest, the stretching of both was a little bit different. I was not able to do the same processing steps because the signal to noise ratio on the bin 2 was much higher. So for me, what I recognize is that in the binning 2 image, the signal to noise ratio seems to be higher. As you can see, the star streams here a little bit more clearer, I think, than in the binning 1 image. So let's do the comparison of the details now. And I think this is the most interesting, as when we image such tiny objects like a distant galaxy, then you want to get most of the image from the details. And it depends a little bit of what you want to show. If you want to show the star streams, then yes, you can do the binning. You get a little or a much better signal to noise ratio to make even faintest star streams visible. But look at the details. So are they okay for you with a telescope of 10-inch aperture? So it's not too bad, I think. But let's compare it with the image of bin 1. So this is a side-by-side comparison with bin 1. So from the theory, what we have seen in the CCD suitability calculator, there should be no difference. But what can be seen on the image? There is a huge difference according to the details. So the bin 1 image shows much crisper structures in the image than the bin 2. And I guarantee I have made the same processing, local normalization, multiscale linear transform, and so on. The only difference was the stretch, because the signal to noise ratio is higher. The rest of the processes are really similar. You can also see here's much more noise than in the binning 2. Okay, this is clearly from the signal to noise ratio visible. So yes, you get much higher signal to noise with binning. This is correct in the theory, but according to details, I must say the theory is completely not true. When we zoom a little bit more deeper into the core, then it becomes even more clear. So the bin 2 is wishy-washy, not clear structures visible. And on the bin 1, it's really crisp image. And you get really benefit from stay with bin 1, especially on the luminance channel. But depending on what you want to get, and you want to get a maximum of signal to noise ratio, then it might be useful to bin the luminance channel. But in the normal 90% or 95% of your imaging sessions, you want to get crisp details. And therefore, I cannot recommend to bin 2 times 2 in the CMOS on the luminance channel. So if you have liked this little video and this comparison, so give me please a thumbs up and consider subscribing to my channel.